So Tom and I are going to co-present. I'll try to give you a 10-minute update on Open Compute. How many people are familiar with Open Compute or have attended a workshop or event? That's good. Huh? Okay, good. So I'll try to go through this pretty quickly. I know it's the afternoon. Feel free to ask questions. I'll try to get through it, and I'll leave a minute or two before we switch over to Tom. So let's see. How do we operate this? Spacebar? Okay. Well, that is slow. Ooh, ooh. So what is what is Open Compute? We're a community-driven, open source hardware organization focused originally on the data center, and as that data center is kind of moving out beyond the data center, we too are moving out beyond the data center. That first phase was looking at deployments into central offices, and we're starting to see a movement of that hyperscale hardware now into other locations and into edge-like and access areas. So we're focused really on taking the tenets of a hyperscale efficient data center and making sure that we adopt those same tenets for all of our projects and all of our hardware. And so we have a 4 tenets that we measure ourselves against: efficiency, scale, openness, and impact. And everything we do as an organization, we review and weigh ourselves against those. We are a community of sub-projects, and unlike the software community, we actually try to keep it to less than a dozen. There's no magic number, but we're trying to avoid having hundreds of projects. I like to use the analogy of my garage. And if you're a software engineer, it's nice to be able to go into the toolbox and you literally have hundreds of sockets and screwdrivers and pliers, and you got a drill press and a welder, and you can build anything with that, really. But if you turn around and look behind you, there's also a car, and sometimes it's easier to just buy the car than to try to build it. And in hardware, I think it's a lot like that. That if we can, provide the pre-built car with everything, we're better off. And so our focus is really on making sure that we have not only an open source hardware and all the ingredients are open source so that you can maintain it. Again, back to that toolbox, you have all the tools to maintain it. You know how it works. You have all the BKMs on this describes it, but you're actually able to get the hardware. So we focus on the supply chain as well and the availability of that hardware. And this is just a list of the 9 active projects. Is it 9 or, yeah? No, 10 active projects. We do have, the other thing we try to do is we try to create some umbrella projects. And so much like LF Edge being an umbrella project for other smaller projects, we do the same thing. We try to put all of our server hardware, compute engine type things together under our server project. We do have a rack and power group. We try to put advanced cooling, energy efficiency, DC, AC conversion, those types of things and sub-projects into that one group. We have a telecom focus group, and we, again, try to put everything that's telecom related that can't be served by the other hyperscale hardware. We try to put that in there. So GPON, universal CPE devices, again, often leveraged off of standard network gear. We focus that in those groups. And a lot of times, rather than think about these as different projects, think about them as different communities and different communities of engineers. So if you're a mechanical engineer or a power engineer, you're going to be attracted to the rack and power. If you're an electrical engineer, a firmware engineer, BIOS engineer, you're going to be attracted to the server group. If you're an engineer working in the telecom carrier space, you're going to be attracted to the telecom group. So we really kind of organize around the types of communities. And so we work together on a lot of different things, not only hardware projects, but also help each other in adopting and using those hardware projects. So traditionally, we look at open sourcing the designs and the source code for various embedded software components on it, but also look at tested configurations, white papers, adoption stories, videos, testimonies, and so on. Again, enabling the industry to consume this hardware, and allows this larger community that may not be designers to participate and feel that they're contributing something. And it's fairly valuable to our community as well, that they have an opportunity community to share. Just a side note, as a foundation, we don't own any IP. When we have customers and community members contribute to this open source community, what they're doing is they're assigning their IP to be used and adopted by others under a royalty-free license. And so we actually follow the Open Web Foundation licensing scheme to do that. So that's what we share amongst each other. Let's see. I don't know what that did. We do have a product recognition program, and this is really designed to help adoption. The idea is that we have technical advisory boards. We've got a lot of engineers. They scrutinize the contributions. They make sure it follows the 4 tenets, and we make sure that there's suppliers that are able to supply it, around the world to anyone who wants to purchase it. And for products that meet those requirements, we assign a certification mark or badge to them. And it allows a consumer adopter to easily identify those. The first one is OCP accepted, and it means that it's really, truly an open. You can go download schematics and board files and stack-ups and so on, and PLD code from our website. We also have an option of having products that are built to a similar specification, but aren't necessarily completely open. So in other words, in terms of the feature set, it complies, but the design files may be slightly different, and that's the OCP Inspired Logo. So if you walk out into the demo area, I noticed earlier today I walked over to the EdgeCore booth, and there's a OCP accepted little logo on a couple of their devices. And so it just makes it easy as a consumer. You see the logo and say, okay, I know that's an open source. I know if I really need to understand the schematics, if I have an issue, in the field and I need somebody to go jump on it and figure out what happened, I have a source to go get that. And so it's an assurance policy for business continuity and sustainability. Likewise, we actually implemented hold on, one more. What's it doing? Not doing anything. It went wrong. Sorry about that. We actually implemented another recognition program, and we had a data center group, and they were looking at what you needed at the facilities level to accommodate, highly efficient hardware. So, for example, if you have a rack that can consume 480 volt 3-phase power, that's great. I mean, the power conversion, eliminates nominally, 2 to 6% inefficiencies. But you have to have a facility that can provide that 480 volt 3-phase or 415 volt 3-phase. So there's a lot of common practices. Is your door tall enough to get equipment in, to pre-build it? Are your floors, constructed to kind of carry this dense weights? Do you have the network infrastructure in place? Just some really simple kind of BKMs of the facilities world. And so the group over the last couple of years put together a checklist. It's kind of a self-certifying program, but we're now able to recognize facilities, and we have 5 or 6 new facilities that have become recognized this year. And again, they're a facility that can house any equipment, but in general, they're really designed for the high efficiency, scalable equipment. And so that was something new this year. All of our information is shared on a marketplace, and this is just an example. You can go look at different types of devices. You can also pull up all the specs and download those there. And as we grow and build this knowledge base, we're continually evolving this marketplace. In fact, just recently, we started to identify the software stacks that are qualified on the hardware. And so if I created this slide a couple weeks ago. If you went to that today and you did a search on a couple of them, you'll see server nodes that are qualified with Red Hat, with VMware, switchgear that supports ONI, switchgear that supports Sonic. And as we build out and eventually, working with ONF and identify CEBA qualified devices and Trellis and other reference architectures that our site is really designed to capture that. So again, making it easier to identify, hey, I have a known good recipe, and this is a great starting place. And kind of with that, here's a couple different links on how to go get information. So that was just a quick introduction of OCP. I guess I right over 10 minutes. Here you go, Tom.
All right. So I have the privilege to now, there it goes slow again, to kind of show you something new. I figured that the folks here are interested in telco. I mean, come on. And so there's a fairly new project that I thought I'd want to give a little bit of extra attention to, and it is Open Edge. And you may have seen other talks about Open Edge. I'm not going to talk so much about the mechanics. I'm going to talk about what does it mean to a consumer for this type of ecosystem. So it is an accepted chassis. So fundamentally what we're talking about here is something that collects lots of sleds or lots of modules. And it is not just a one-off. It is something that there's multiple suppliers in the ecosystem that are interested in working with and supplying toward. So it is, you're not locked in. It is interoperable across suppliers, and it's an interesting ecosystem. So this is not a rehash of ATCA. And so if you're a telco guy, you probably remember the pain of that and suffering of that technology. It is minimally interconnected, so it provides power and it provides connectivity for management interconnect, management GigE LAN, right? That's all it connects in the back. And, I'm sorry? RMC. There's an RMC. Okay, so what happens is often the telco doesn't have enough, what would I call it, capacity need to have large integrated web scale racks that have centralized power units. This centralized power system is one of the ways that they get power efficiency in their deployments. If on the other hand you've got a rack full of servers and each one has 2 power supplies, you're not going to do so well. In this chassis system, all of the modules share a common set of power supplies. They gain some of that power efficiency by having the shared power supply environment. And there is a nice, interesting little way to daisy chain the management so that if you deploy these things, you don't need a separate management switch at the top of your rack that interconnects all of those components. So a lot of times, obviously, the tagline here is this is a way to kind of inch your way into getting a lot of the OCP benefits from web scale, but at a much smaller size, right? It's like mini-me. And so that's a way that we think helps telcos start adopting in the OCP world. And it comes in the beginning, we have modest compute options with 1 height and 2 height half-width servers. But because it is a chassis that's fundamentally here, servers is not the only thing we could do in this space. And Open Edge can be a much more general purpose kind of platform. And because it can be deployed in various kinds of spaces without having to refit facilities, because it can fit into 19-inch racks. It can use DC power, so it can go into, it's NEBS compliant, so it can go into existing central offices. So a lot of times we found, and I've said this already, is that the problem really is often about scaling down, not scaling up. When we talked about in the last Crano talk, a lot of times we want an appliance. We want something that's a one-trick pony. We want to deal with it kind of like a cloud because that's what we're tooling up to do as a company. But ultimately, it needs to be very small and efficient, and this helps with that. Okay, so what we think is that these things, this edge cloud can gain from more than just servers, that there's other kinds of components that can go into the chassis, and that by putting them into the chassis, you not only get the basic power efficiency gain that I talked about a few seconds ago, but there's also an operational gain. So in a company like AT&T, you can imagine there's a cost involved when a technician has to go into a central office. They have to put a piece of equipment into the rack. They have to put the wires onto that, the DC power onto that, and then usually there's some fuses at the top of the rack that need to be connected to all of that. And all of that has to be wired up and put in place. And if it's a classic server, there's 2 of those power supplies that you have to do this for. So let's just say that that's a unit cost of 1 to do that. Okay, if you have a rack full of servers, let's say you need to put 5 servers in a rack, you're going to incur 5 unit costs to do that. On the other hand, with an open edge chassis, this installation of the chassis, the wiring of the power supplies into the top is going to have a unit cost of 1. Now, you'll still have some costs for putting in the sleds after the fact, but that's going to be much less than when you had to send the tech out there and actually you do the screwdrivers and put down the DC cables and so forth. So there's an OpEx gain to be had for equipment that goes into this type of chassis. All right, so what else could I do? In addition to the compute, we can imagine GPUs and accelerators. People talk about that all the time, and it almost comes without saying, right? But in addition to that, imagine switches that fit into this model and can be slotted in. Imagine access devices like OLTs or radios that could go into this type of chassis and other things. You know, they could be accelerators of various types. All right. And so AT&T has an ongoing and underway specification. It's under review at OCP for a programmable PON device. And so this is a device that's based on one rack. It has multiple form factors. It can be a pizza box, and we're targeting it to also be able to be a sled for this chassis. And so that type of device could have a number of 10 or 25 gig PON ports, and it can have 100 gig uplinks. In that same form factor, and we're knock on wood, maybe even using the same basic merchant silicon to support it, we believe we can also do front hall switches or cell site front hall gateways. And that would allow us to interwork, for example, CPRI into radio over Ethernet, or do radio over Ethernet type of switching functions, again, in a cost-reduced form factor. And then last but not least, the basic kind of switching and kind of networking you'd normally find, there are already, and I've shamelessly stolen some of their pictures, there are already devices on the market that are half width, 1 height, 1 RU, that would work very well in this environment. So we see all those things as opportunities for open edge. So we're at the point now where we have a spec for a chassis, and we have some OCP inspired offerings for servers to go in that chassis, but we're interested in working on an OCP base spec for servers, so that servers that come from different suppliers with different CPUs, different kinds of capabilities or basic topologies, wind up having a common, what I would call, management surface. That even though they'd be different servers from different suppliers, they might be based on ARM or Intel or AMD, that they have the same basic BMC capabilities. They have the same basic BIOS capabilities as far as makes sense for those kinds of things. And therefore, they have a common operational look and feel across OCP. And we think that would add value into the marketplace. Okay. And you've probably had the chance to kind of read about the details there. So how does this then help with ONF and what we're doing here? Well, we think that this is a device that enables and facilitates convergence, in that once we get to edge cloud infrastructure and it supports multiple kinds of access, then we're interested in the kinds of characteristics that you see on the chart, that we'd like with the white box infrastructure. We want to have disaggregation. We want to be able to support virtualization and orchestrate workloads there. And we want to orchestrate it and deal with it like we do with the cloud, because that's what we're tooling up to do. And if I bring that back to a picture you probably saw me flaunt earlier, there are these software projects at ONF, which look to place various kinds of capability on top of common infrastructure. We believe that what's going on in this space is that you typically have compute, you typically have switching, you may have access peripherals, and these all fit then almost like Lego blocks into an ecosystem that could be useful on this open edge. But, and here's the but, it's a great idea. We think there's a lot of reason, a good reason behind doing something like this. But for a company like one company, it's not going to make sense. There's not going to be economic benefit or volume if AT&T is the only company in the world that uses this. So we really are looking for an ecosystem. We've seen a start to the ecosystem in terms of multiple suppliers. We're looking for multiple users, multiple contributors, and ultimately, you can read all the middle part, but essentially, it needs to meet your needs. This is not about us, it's about the big we, and we need your contributions at the end of the day. So it's ultimately a shameless plea to please come and participate and make this useful for all of us. So with that, I say thank you, and I think we have time, hopefully we have time for questions.
Yeah, I think there is time for questions. And you might start with the power question if you can address it.
How about that? Okay. Do you want to take it?
What was the question?
Well, so the question as I got it is that there's, as we start moving forward with all of these new architectures and technologies and software, there becomes an increasing need to be cognizant of power efficiency. And yes, we agree. And one of the basic, you're okay. I knew you wanted that one.
Yeah. So we launched this. We actually started forming this project 9 months ago, December last year, something like that. So we announced it in March. We actually have the Open Compute project has a regional summit in 2 weeks in Amsterdam, and I get an opportunity to announce a lot of new things that are in support of this. And I'll tell you right now that we're going to see, energy efficient single socket Xeon, Intel-based solutions, 2-socket Intel-based solutions, and we're going to see at least 2 different suppliers are going to announce ARM-based solutions. And so we're starting to see a pretty good range of power efficiency and particularly low-cost options in this architecture.
I'm
So,
sorry, failing to understand your point, though. You said so there's projects that have been underway, and I follow your stuff. I'm on the Rack and Power and Steve's list and all that. And I've given talks at OCP before about this, but what specific project is addressing this? And then, there's always new architecture, processors, and all that, but how is that? I mean, I understand ARM core maybe is slightly lower, but from a power density footprint perspective, these things actually only go up because they put more stuff in there. So it's all about the utilization. It's where energy efficiency savings occur. So can you please explain in that?
well, you were saying, we're scaling out 5G. We're going to have a grid problem. The point I was making is that, this is one of the first, OCP products where we have ARM support, and really from kind of day one. And so we do get some really low-cost solutions in here. That was all.
Oh, okay.
Yeah.
So you're talking about saving money
Power.
on
Yeah.
OpEx.
Yeah.
Excuse me, on CapEx. as
And
opposed
OpEx.
to- well, okay, I guess that's the part I was still failing
So
to.
I think he was more interested in kind of people talking power efficiency. So one of the things, you apparently already know this, right? So one of the things that OCP stresses is that the specifications that come forward are based on highly efficient power supplies. They're based on basic architectures that make power efficiency easier than a typical rack individual servers with multiple power supplies per server, right? So they're fundamental basics in that space. That's already been behind us. Looking forward, OCP server designs are starting to pull in what I would call laptop ideas, that the whole idea of powering down bits and pieces of the server or even bits and pieces of cores or chiplets as needed in an architecture is another tool, is one that's been discussed.
That is addressing utilization of the efficiency.
Agreed.
Everything else I heard before that.
I'm sorry. But, you know, having, yeah.
So there are a couple of things. One is you lose efficiency when you run, dual power supplies, unless you can turn off one, right? Yeah.
Redundancy versus
You-
virtualization.
Exactly,
right,
yeah.
of
So,
maximizing load.
right, so the fact that we have an RMC in there, a rack management controller, gives us a new level of granularity to turn on and off nodes and turn on and off power supplies. One of the options we'll announce in September is a battery backup, so we'll actually have an option of using a BBU in that in place of one of those supplies. So that there's some interesting, power efficiency
So
potential
you're talking about
gains to do that.
utilizing your BBU stuff, but now in terms of like peak shaving and energy storage, the stuff you're doing like DPS and all that versus using it for system level modularized, just short term right through.
Well, I think,
Yeah, potentially. Yeah.
so I just don't want to manage time a little bit, not go too deep into one question and make sure there's
Okay.
some air time for others,
We'll catch you later.
Tom,
I'm sure.
how about we go?
Yeah. Thank you, Tom and Bill. For optics, when you have these new modules that have a lot of optics on them, where is OCP taking the discussion of how do you specify the thermals, how do you specify the plugins, and is it open from the perspective of does it meet the specs? It's open to take in a
Yeah, OCP gear is not locked into optics, so.
Okay, all right.
Let's
Thanks.
start with that, right?
So today the enclosure defines a power envelope and thermal envelope, and so it's pretty open after that. By the way, we're seeing kind of the first round of products right now. I think we're looking at some other options within that enclosure. So, we're going to see a need for more optics in the front of that, probably define a different type of slab, maybe too wide, single high, things like that. So,
And Wickson?
Yeah, a quick question about, you mentioned a switch for front hall, right? And the location in the edge?
Yeah, okay. So thank you. That is a good question. And so typically a front hall switch in our mind, it may be a bookended solution. So you may have a single unit, it might be a pizza box at the cell site. But if the cell site is running a CIPRI radio and it's still LTE, it goes to a locked-in BBU at another location, and we want to bring it over a common radio over Ethernet front hall system. What we do is we change CIPRI into radio over Ethernet, and then next to the BBU, we turn it back into CIPRI again. That's the area where pooling and putting front hall gateways into a chassis in multiple units makes sense. There.
All right, still have, and any other questions? I think time management, if anybody has a pressing question, otherwise, okay, thank you very much.
thank you.